All right, pre-algebra, last section of topic 5. I can apply the properties of integer exponents to create equivalent expressions. So we are still just kind of doing an extra application of these same integer properties that we've been looking at. So let's check it out together here. This is 5.6. So we've been studying the properties, and now we're going to start applying those to write our own equivalent expressions. So not just using them to simplify, but now we will use those properties to help us write new expressions. So just as a reminder, equivalent expressions are ones that always have the same value. So just like 2/3 is equivalent to 4/6, both of those fractions have the same value. It's just different ways of naming that value. So another example would be 2 times 12, as shown here, which we know we could simplify or evaluate to 24. And 20 plus 4 would be another expression that would also have that same value of 24. So those are equivalent. So we're going to look at creating those using our exponent properties. So we need to write 4 expressions that are equivalent to 2 to the 13th power, and we want to explain our reasoning for each. So if you think back, the very first thing we looked at was multiplication with exponents, and we talked about if you have the same base, so in this case my base is 2, and I multiply two numbers that have a base of 2, then when this base is raised to a power and I multiply those, I'll actually add those exponents. So I'm really looking for 2 exponents that would add to 13. So we could have lots of different variations of this. We could say 2 to the 10th power times 2 to the 3rd power. We could say 2 to the 6th power times 2 to the 7th power. So take a second to see if you can think of another version or two of multiplying numbers with the same base that would have powers that would add to 13. Okay, you may also remember when we talked about dividing, we talked about when we divide exponents, we have, let's say we have the same base again. Let's use x as an example. If I have x to the 5th divided by x to the 3rd, same base, I will keep the base, and I will subtract my powers. So we could use that idea here to write some equivalent exponents that would have a base of 2 and whose powers would subtract to 13. So I'll give you a second to jot a couple of those down. These that you put down on your C notes we will share out in class. If you would really like to challenge yourself, you could also think about how we could do this using power of a power. So we talked about you have x squared in parentheses, and we've raised that all to the 3rd power. Then in this case, I'm going to multiply my exponents. So you may see if you can come up with an equivalent expression for 2 to the 13th power that might use this power of a power. You may even, if you are feeling really confident, you may even try to figure out a way to use an exponent of 0 to help you simplify to 2 to the 13th power. So pause the video and take a few minutes to see if you can come up with some others, and we will share these out in class. But let's practice some that are a little more structured and not so open-ended so that you can think about how to apply this idea. If we're looking for expressions that are equivalent to 5 to the 8th power, let's check out number 1 here. I have 5 to the 1st power times 5 to the 8th power. So I notice that I'm multiplying and I have the same base. So my property says that I will keep that same base and I will add my exponents. So 5 to the 1st times 5 to the 8th is really 5 to the 1 plus 8 should be 5 to the 9th power. So this one would not be equivalent to 5 to the 8th. Let's check out number 2 here. We have 5 squared times 5 to the 6th. So I see I'm multiplying. I have the same base, so I'll keep my base, and my property tells me to add the powers. And of course, 5 to the 2 plus 6 power would be 5, would simplify to 5 to the 8th. So this one would be equivalent. On number 3 here, we are looking at a quotient of exponents. So I have a base again of 5. So I can keep my base the same, but now my property says that I need to subtract my exponents. So 16 minus 2 would really simplify to 5 to the 14th power, which is not equivalent to 5 to the 8th. And if I look at number 4 here, now I have power of a power. So I have one base, which is 5, and it's being raised to the 2nd power, and this whole thing is being raised to the 4th power. So power of a power property says that I'm going to multiply my exponents. So this would be 5 to the 2 times 4, which is equivalent to 5 to the 8th. In class, we'll be doing some activities to help you practice sorting out all these different properties because we have talked about a lot of them. And now that you know all of them, we want to make sure that we can remember which process goes with which property. So let's take a look at putting the correct symbol between these expressions to make a true statement. So we're trying to determine if the first is less than, equal to, or greater than the second expression. So in part A, I have 3 to the 6th. And on the right, I have 3 squared times 3 cubed. I see I'm multiplying. I have the same base, so I can keep my base and add the powers. So 2 plus 3 would be 5. So on this side, I really have 3 to the 5th, which 3 to the 5th is going to be less than 3 to the 6th. On part B, I have 7 to the 4th power, and I want to know if that's less than, equal to, or greater than 7 to the 8th over 7 to the 4th. So I notice I have the same base, and I'm dividing, so I will subtract my powers, which gives me 7 to the 4th. So in this case, these two expressions are equivalent. And on part C, I have 1/4 to the 16th power. So remember, I am applying this power to the numerator and to the denominator. So this is really like 1 to the 16th over 4 to the 16th, right? On the right-hand side, I have 1 to the 4th, or I'm sorry, 1/4 to the 8th power times 1/4 squared. So I see that I have the same base, which is 1/4, and I'm going to add my powers. So 1/4 to the 8 plus 2 power is really 1/4 to the 10th power. So this means that I'm really doing 1 to the 10th power over 4 to the 10th power. So as I compare this to this, what I have to consider is that when I raise a 1 to any power, it doesn't change because I can multiply 1 by itself once, or I can multiply 1 by itself a million times and it's still going to equal 1. So I'm really comparing my denominators. 4 to the 16th power is going to be a larger number than 4 to the 10th power, right? So this means that each of these 1 pieces is going to be smaller. So when I'm looking at which value is greater, 1 over 4 to the 16th is going to be less than 1 over 4 to the 10th power because this denominator is smaller, which means each of my fractional pieces themselves are going to be bigger. So those fractions get tricky. The rest are pretty straightforward. Let's practice again here. Less than, greater than, or equal to. If I'm looking at 9 to the 12th and 9 to the 36th divided by 9 to the 3rd, make sure that we remember the correct process for quotient of powers. If I have the same base, I'm going to keep that base and I'm going to subtract my powers. Don't be tempted to divide the powers. So this is actually 9 to the 33rd power, which obviously if I multiply 9 by itself 33 times, that's going to be greater than if I multiply 9 by itself 12 times. So we would say 9 to the 12th is less than 9 to the 33rd power. I think you guys are getting it, but why don't you pause the video, come up with your answers for these, and then unpause to see if you get it correct. As you take a look, you're probably noticing we have different bases. So take a second to think through how you could compare these and then unpause so you can check your work. All right, now that you have given it some thought, let me talk you through. So we have 3 to the 18th power on the left. Over here I have 9 to the 10th power times 3 to the 3rd power. We don't know how to multiply these because I have different bases, but what I notice is that a 9, I could make a 3, right? Because 3 is a factor of 9. So I'm going to take 9 to the 10th and I'm going to break it into 3s. So I'm going to think of 9 as 3 times 3. And I'm going to raise that to the 10th power. I haven't changed the value. This expression is still equivalent to 9 to the 10th. I have just rewritten it in a different way. So what this means is that I'm really doing 3 to the 10th power times 3 to the 10th power because I have to apply this exponent to each factor inside my parentheses. So what I really have is 3 to the 10th times 3 to the 10th, and then I'm also multiplying it by 3 to the 3rd power. So I have just rewritten 9 to the 10th as 3 to the 10th times 3 to the 10th. Now I can go ahead and use my multiplication property of exponents, which says that I keep my base the same, and I add my powers or my exponents. So this is really 3 to the 23rd power. And I know that 3 to the 18th would be less than 3 to the 23rd power. So now that you've gotten a feel for how to break this apart to make equivalent bases, let's try it on part B. I have 4 to the 21st power times 2 to the 28th times 8 to the 4th. So I have 3 different bases this time, but I know that all 3 of these bases could be broken down into 2's. So I'm going to start by taking 4 to the 21st, and I'm going to break 4 into 2 times 2. And I'm going to raise that all to the 21st power. So I am really doing 2 to the 21st times 2 to the 21st. So if I apply my multiplication property, my base stays the same, and I add my exponents. So this is really like 2 to the 42nd power. So over here, I can keep 2 to the 28th power the same because I want to have a base of 2, but now I need to break up 8 to the 4th into bases of 2. So I know that 8 is 2 times 2 times 2. So now I'm going to apply this exponent to each of these factors. So I still have 2 to the 28th power, but now I'm multiplying it by 2 to the 4th times 2 to the 4th times 2 to the 4th because I applied this exponent to each factor in my parentheses. Now I am multiplying 4 factors that all have the same base, so I keep that base and I add all the exponents. So I have 28 plus 4 is 32, plus 4 is 36, plus 4 is 40. And now I can see that I'm comparing 2 to the 42nd power to 2 to the 40th power, which would be greater than. All right, let's try one more like this, but take a look at when we have division. So I have 27 to the 5th, and I'm comparing it to 9 to the 8th over 3 to the 4th. So first of all, I noticed three different bases, a 27, a 9, and a 3. But fortunately, all of these can be written as, I can break them down